Let's do this question together. Given g of x is equal to x squared, write the equation of the inverse of g in the form y is equal to. After that, we're going to sketch the graph of g and its inverse. Okay, then we're going to write down the domain and range of g and its inverse. Right, let's start with A. Write down the equation of the inverse of g in the form y is equal to. So what did we say? We say that the first thing is to interchange x and y. So this is just like y is equal to x squared, y is equal to x squared, interchange x and y, x is equal to y squared. Then after that we make y the subject, so we square root both sides. We square root both sides, so it becomes y is equal to the square root of x. Okay, right. So that's the first part. So this is the equation of the function and then the equation of its inverse. Then B, sketch the graph of g and inverse of g on the same set of axes. You may use the following table. So let's look at g. If x is negative 1, negative 1 squared, that is 1. If x is 0, we just substitute 0 squared is 0. If x is 1, 1 squared is 1. Right? Then we can sketch this graph of f. So which is roughly negative 1 will give you 1, and then 1 will give you 1. So it's a parabola quadratic function, which is like this. That's a graph of f. And then let's do the inverse. If x is negative 1, square root of negative 1 is non-real. So we don't have an answer here. Non-real. Square root of what? Of negative 1 does not exist. Square root of 0 is 0. Then square root of 1 is positive or negative 1. Okay, so it means we have two answers there. So we have 0, with 1 we have positive 1 and negative 1. So this is like 1, 1. Then this one is like 1, negative 1. This is like negative 1, 1. Okay, these are the coordinates, right? Then we can sketch this graph, the graph of the inverse of what? Of g. And this is a reflection. This is a reflection about the line y is equal to x. C. Write down the domain and range for g and its inverse. Right? So for g of x, what would be the domain? We're saying for g of x, the red graph, x is an element of what? Of real numbers. X is an element of real numbers, or you can say x is from negative infinity to infinity. Right? These are the x values, the input values. Then the range, the graph is from 0 and above. The red graph is from 0 and above. So the range is y greater than or equal to 0. Or you can say y element of 0 included to infinity. Right. Now what about for the inverse? For the inverse domain. Now the x is the one that starts from 0 going to the right like this. So it's x is greater than or equal to 0. We can say x an element of 0 to infinity. These are the x values. Below 0, the graph doesn't exist. Range, the y values now. It will be from negative infinity to infinity. That is for the black graph, the inverse. The range is y, element of real numbers, or you can say y is from negative infinity to infinity. Right. Now, I want you to take note of the following. This graph G is a many-to-one function. This graph is a many-to-one function. And then its inverse is not a function. So the inverse of a many-to-one function is not a function. You can also use the vertical line test. See that? It casts a graph there, it casts a graph there. We use the vertical line test to test if a relation is a function or not. If it cuts it more than once, then it's not a function. In our next lesson, we're going to talk about how we restrict the domain. Okay. But now just know that the inverse of a many-to-one function is not a function. Then take note of this thing also. Let's check the domain of G and then the range of the inverse. Do you see it's like the range and the domain sort of swap like that? Here it was x element of real numbers, now it is y element of real numbers. Or you can write like this, you see that? So the domain becomes the range becomes the domain. But remember, the domain is your x values, the range is your y values. That one does not change. Okay? And then also look at the range for G, and then the domain for the inverse. Okay, so it's like these things swapped around. For the graph and its inverse, x and y interchange.